Okay, so yesterday you did, oh dear, no thank you. Yesterday you did methane, right? And the molecular formula for methane was CH4. And the name, methane, and the Lewis dot and cross diagram. We remember that we started with carbon. And the display diagram, we're converting that shared pair of electrons into sticks. The structural diagram was exactly the same for methane. And the Vesper diagram, which is where we kind of stopped, helps you visualize that there's a tripod of hydrogens and one hydrogen on top. So this is a dash going towards you and a wedge going away from you. And so we built those models yesterday, and I happen to have one in this right here. And you can see stick up is this one, stick across is this one, stick towards you on my hand is this one, and stick away from you, this one. Did you get it? So this is the wedge towards you, this is the dash that's going away from you, this is on the plane, and this is up. So if I was a carbon, there's a hydrogen going this way, a hydrogen going this way. Those are my sticks, like just plain lines. Then I've got a wedge going that way, and I've got a dash going that way. Okay, so this is a tripod, there, and there, with the camera on top.
Why is one on the, like the hydrogen on the right a dash then? Because it's going in the exact same direction as the other one.
Because it means, no it's not, it means it's on the plane of the paper. So that means, if I were to smuck that onto the plane of the paper, that would lie flat, that would lie flat, but this is trying to go into the board, and this would be sticking out.
Okay.
So there's one going in, one coming out, one on the plane, one on the plane. And no matter how I rotate this molecule, it looks exactly the same, no matter which hydrogen is sticking up, meaning it's symmetrical, meaning it's non-polar. Well done. So although the bonds are polar, although these are unfairly shared electrons on those sticks, the overall thing is still non-polar. So if these were four mountain teams, and these guys are stronger, they're pulling the electrons a little bit more, right? So they're stronger, so they're pulling these tow ropes. So this is like a massive tug of war. The flag in the middle is the black thing, and the four yellow sticks are the four mountain teams. They're of equal strength at the moment, all pulling with equal forces, meaning that black flag isn't going to move. Okay, and in physics those are called vectors. Remember vectors? You do vectors like car crash and which direction does the wreckage move. Okay, so all that's the same. If you don't know what a vector is, don't worry. It just helps tie it in if you do. Okay, so everybody okay with that line? Okay, so let's do it for the next chemical formula. Remember the general formula is CnH2n plus 2. So I would have C2, this is C1, right? So C2, H what?
6.
Emily, phone in the bag, not in your pocket. H6. What's that called? Ethane. Could you draw the dot and cross diagram for it? Where would I start, Raj?
First I'd put down 2 C's,
Okay, like that?
yeah.
Good, that's good.
And then 4 X's are like 1 on the top, 1 on the bottom. Same thing with the other side.
What am I going to do with this? Those two that are right beside each other? Share them.
Okay.
Oh, that's a big eraser. Okay, so C, X, 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 O, C, O, O, O. Everybody okay with that? Not really. Is that too small? I'm trying to draw it neatly in that line, but it's, you know, not very neat. My writing's not neat at the best of times, and then you go ahead and give me this computer program. Okay, oh. And now, conveniently, I have 1, 2, 3, 4, 5, 6 bonding electrons that need a partner. And I happen to have 6 hydrogens. So without even really thinking, you just shove hydrogens around. So hydrogen, 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 hydrogen. I'm going to have to erase nothing. Okay? The display diagram converts all those X's and O's, which I say kiss and hug in Chem 20. So all these kisses and hugs, which are shared pairs of electrons, we convert those into sticks. So stick, 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 stick. And my university professor, my organic chemistry university professor, used to say there are 3 sure things in life: death, taxes, and 4 bonds to carbon. So when you start drawing your sticks, you make sure you've got 4 sticks on all your carbons. Because I can guarantee at some point in this unit, you're going to put 5 sticks on it. And I'm going to go, how many sticks on carbon? You're going to go, oh yeah. Okay? So 3 sure things in life, 4 sticks on carbon. The structural formula we can make slightly different. So displayed means everything's displayed out, like a peacock displays his feathers, like a display board for a science fair. Everything's out on display. Structural formula just gives some hint about its structure. And molecular formula is all of it crammed together. So do you see these differences in the word? Like, so that's, you're kind of learning the definition as we apply it. So the definition for molecular formula, just all smucked together. Definition for displayed formula, everything displayed out. And the definition for structural formula gives a bit of its structure. This doesn't give any structure to it. It's just like how many carbons I have. The structural formula, I could do this. CH3, CH3. Do you see where I'm getting that from? CH3, CH3.
So the one we did, like when we did methane yesterday, was there another way to follow that?
Not so that it's different from the molecular formula. So you need 2 sticks on that one.
Okay.
Could you also draw it like that or no?
CH3?
Yeah.
No.
Or no, C2H6. Could you also draw it like
All the sticks?
Yeah.
Yes. Yes. So Devin's asked, can I always do the displayed formula for structural formula? The answer is yes. You can always do all of these lines for the structural formula. Okay? Right, the next one would be C. Oh, and the Vesper diagram, by the way. What was this called? What's that shape called? Pardon? No, this shape on the Vesper diagram. Do you remember what fancy name we give it? Well done. Tetrahedral. Tetrahedral. Yes, you need to remember that. Okay? They don't really ask you any others, but they ask you what tetra. Okay? Tetra being 4. Okay? Okay, so tetrahedral. So the Vesper diagram for ethane would look like this. C with a stick. That is that C. This is a dash and wedge over here. Everybody okay with that so far? And then off of this carbon, I would also have a wedge and a dash and a stick coming out. Yes, Evan?
Does it matter what angle you're putting the
Yeah,
hydrogens and everything at?
Kind of. It should look like a tripod with a camera on top. for the first one, and then a flipped upside down tripod with the camera on top for the next one. If you don't flip it, I'm still happy. The point being that they are both two tetrahedrals. Two tetrahedrals. So if this first one was nonpolar, then two of them stuck together are still going to be nonpolar. And something that you should have teased out in Chem 20 was actually every hydrocarbon, carbons and hydrogens only, is nonpolar. Evan, would you build this for us, please?
Yeah.
So you can see the two. In fact, actually build 3 carbons.
C3H8?
Yeah. We're okay with the 2 tetrahedrals together? Do you get it? And do you get why then that's going to be nonpolar? And actually I'm just going to have a whole row of tetrahedrals which will still be nonpolar. So the whole thing's always nonpolar. So do you have to look at the polarity in it? No, just jump to the nonpolar bit. Unless I've got an oxygen or a chlorine or something crazy. The end. Okay, so the next one then, C3H8. It's called propane. Have you heard of propane before?
Yes.
Yes. Bet you didn't know it looked like this. Okay, can you do the dot and cross diagram on your own? And I'll put it on the board in a minute. Do a display diagram on your own. See if you can do a structural formula on your own. And don't do the VSEPR. Okay? Don't do the VSEPR. Okay, check your answers with mine. Is that what you got? So 3 tetrahedral shapes around each carbon. There's the dot and cross diagram, there's the line diagram. And I want you to start trying to be able to do these dot and cross diagrams without thinking much. You should think for tricky ones, so you should know how to do it. But by now you should know you've got a line of carbons with hydrogens around them. So you start going carbon, kiss, hug, hydrogen, kiss, hug, hydrogen, kiss, hug, hydrogen, kiss, hug, carbon. Right? Without really thinking, you just know it's going to go like that. Because they all do. It just matters how many carbons you put in a row. Okay? Boys in the back, do you get what I mean by not thinking? Okay. So, and then just so you can see it, can you see how this is? I'm going to...
So the drawing of the VSEPR diagram would just be like the C, all the C's would be a signal line and you'd have 1H, 1H.
Correct.
And then the double H's with the...
If you put your H's on your dashes and wedges, then you run out of trouble. Then you don't run into trouble. Yeah. Okay, so now I'm going to get you to do all the way up, except for the naming, because you're not going to really know the naming. But I'd like you to do the molecular formula, the dot and cross diagram, the display diagram, and a structural diagram for all the way up to C10. H what? 22. Okay? This will be the last time I get you to do this many all like this. But I think it's good for us to do it once so that we've got our reminding ourselves of dot and cross diagrams from Chem 20 sussed. Oakley dokley? Okay, so you can check your work. Note how I've done, I'm just saying this for the people that are missing and going to watch this video later. Note how I've done the structural formulas with this brackets and the 3's bracket 4, meaning I have 4 CH4s all connected in a line. Just makes it faster. And then the names you've entered now. Okay, so the names, you're going to have to memorize them. Okay, you have to memorize up to 10, I want to say. I better check. Might be 12. Definitely 10. Somebody in my class a while ago, well, first of all, this pent, hex, hex, oct, right, is the same thing as your math. So that should be fine. Non-name, people forget a lot. And the rest we're okay with normally. Okay, pentagon, pentane, hexagon, hexane. They all end in ane. Because what are we talking about at the moment?
Hydrocarbons.
Yeah, but what kind of hydrocarbon?
Alkanes.
Alkanes. So these are oh dear. These work? These are alkanes. Alkane, ending in ane, so all these end in ane. Okay? Meth means one carbon, so one carbon alkane is methane. Pent means 5, so pentane is 5 that exist in the alkane general formula. C5H12, all single bonds, a saturated hydrocarbon. Okay? Okay, so a long time ago, in order to memorize these ones, because they don't follow our math naming system, somebody in my class came up with monkeys eat peanut butter. And for some reason, students like it. It fits, it makes sense, it's something they memorize. So monkeys eat peanut butter. Monkeys eat peanut butter to memorize meth-eth-pro-bute. I also had a student come up to me and say, I made up a whole song to memorize this. I'm like, oh, okay. And he said, it's called the meth-eth-pro-bute song. I'm like, then you've memorized it without the song? If you know the name? And he's like, oh, good point. Yeah, this is a highly academic school. Yeah, great.
Are those not in the data booklet? Like, because when you look
They
at the
are,
formation.
but what's the problem with trying to find them in the data booklet? Time. Because they're listed alphabetically. So you're really looking for a C7 somewhere, and it just takes too much time for a question that's supposed to take you 10 seconds, so that you can bank the time for a calculation question. Okay? So memorize, and I don't know, I wouldn't know if all of them are in there. I'd have to cross-reference, but.
Maybe goes up to
Okay, and then we're going to use this naming system for a lot of things. We're going to name branches, we're going to name alkanes, we're going to name alkynes, and certainly not all of those are in there. So you will have to have it memorized. Okay, so monkeys eat peanut butter, and then the math shapes. Happy? Everybody okay with that? Everybody got that down? Okay, so back to your booklet. Okay, naming. Okay, let me switch it back again. Oh, how to do that? Rotate, view, clockwise. Okay. Okay, so naming these compounds is called nomenclature. Okay, and that's not just Mrs. Reese Brown being British. That is the name, and you will see that in a, like, what is the nomenclature of this compound? And you will have to then know the nomenclature means naming. So the nomenclature of branched alkanes. So far we've only talked about straight chain alkanes. That's what they're called when they're all in a nice straight line. Straight chain, okay? So what happens though if there's a branch off of them? Then we have to start naming the branches. So here are a bunch of steps, which I could read to you, but you'll just be bored, and you can read it yourself. Everybody okay with that? But you have steps that you can follow. Let's go to examples. So down here, and I'll talk you through the steps with an example. So down here you have a straight chain in the middle. Do you see this straight chain here? Like that? Do you see that? How many carbons are in that chain? 6. 6. 1, 2, 3, 4, 5, 6. What do we call 6 carbons? Hex. So it's hex. Is this an alkane? All single bonds between the carbons. Yes. So this is hexane. So this is something or rather hexane. Now I want you to think of this as like a charm bracelet. So here's the branch, that's the bracelet. That's going to go wrapping around my wrist. And here are the charms that I can attach to the bracelet. You okay with that? So this is like really called the chain. And these little charms are called branches. So it's as if this is, the green thing is a trunk of a tree, and these are the branches off of the trunk of the tree. Okay? Or this is a chain, and these are the little charms on the chain. You can visualize any analogy you like. So, and if we were to build it, our chain would look like this. I would take one of these hydrogens off that was in the H2, and I'd put another methane there. Does that make sense? Sort of? Okay, so you can build that actually. Well, no, then you don't have enough carbons. Okay, so how many carbons are in my charm? This charm here. How many carbons? One. And what do we name the charms? Well, what do we name one? Carbon, I mean. What do we name one? I was jumping ahead of myself. Meth, right? Meth. But it's not an alkane, it's a charm. It's not the branch. Or it's not the, oh my gosh, I'm really mixing myself up here. It's not the trunk of the tree, it's a branch. So I can't end it in ane. You end these branches with a YL. That's how you know in the reading of it that it's a branch or a charm. And this one would be called methyl as well, because it's one carbon and it's a charm. So one carbon, meth. In fact, it's a branch or a charm, YL. Everybody okay with that? So that's how the naming is sorted. Now I'm going to tell you where I have put the charms on the bracelet. Are they right beside each other? Are they on the same link? Or are they really far apart? So in order to do that, you give the carbons numbers. Now I can number the carbons left to right, or right to left, depending on whichever number gives me the smallest number. So I could go 1, 2, 3, 4, 5, 6. The carbons are on number 2 and number 4. Everybody okay with that? Or I could follow the blue pathway and go carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. And then my branches are on carbon 6 and carbon 3 and carbon 5. So the blue numbering system is higher than the red one. You see that? So I follow the lower one, which is the red one. So I'm gonna erase the blue, and I'm only looking at the red numbering system. Okay, so it's 2 and 4. So I've got a methyl on carbon 2. I should be doing that in red, shouldn't I, really? I've got a methyl on carbon 2. I've got a methyl on carbon 4. I have 2 methyls. 2 methyls? Everybody okay with that? So we call those di for 2, or tri for 3, or tetra for 4. So di-methyl. And I'm done now. I just need to add the hexane that I already sorted out from a long time ago to the end.
Do you have to do monomethyl or is it just methyl?
Just methyl, not mono. Okay, so it feels like quite a lot at the moment, but do you remember when you're learning about voltaic and electrolytic cells, and it felt like a lot because you have to learn it all at the same time? That's what you're feeling right now. And as you practice a few of them, you'll be like, oh yeah, no problem. Okay? But at first it does feel like quite a bit. Andy, do you remember this stuff?
Yeah.
All of it?
Yeah.
Okay, so walk us through this next one then.
Okay, there is 10 carbons.
10 carbons in your,
Chain, so it's decanes.
okay, let's just see. Is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Everybody okay with that? And so Andy said, in my longest chain, because that's what you gotta do, you gotta find the longest chain, okay? which is right now it's obvious because it's just a nice straight line. Sometimes they bend on us, so we'll have to just pay attention to that later. So 10 carbons. So deck A. All right, Jillian. What do we do next? Give numbers to all the carbons. Okay. So you can number it left to right or right to left. Correct. Just before that, for those in the audience that have only done this for the very first time, we're going to circle our branches. Can you find your branches? So there's one here, and there's one here. What's this branch called? Methyl. What's this branch called? Methyl. What's this branch called? Ethyl. How many carbons are in that charm? Two. In a nice line. 1, 2. See that?
So it doesn't matter about the hydrogens?
It doesn't matter about the hydrogens, that's correct. So F, because there's 2 carbons hanging off that charm. See how that charm is long? This charm is longer. It's 2 carbons long, and this charm is a short little 1 carbon long. So this is called F for the 2 carbons, and still YL because it's a branch. What if it was 3 carbons long? So 1, 2, 3 carbons long with the appropriate number of hydrogens. Propyl. Propyl. Prop. Because it's monkeys eat peanut butter. Meth, F, prop, bute. So therefore butyl for the branch with 4. Bute, YL. Okay? So, but of course it's not, it's methyl. That one. Okay. Okay, so now we're going to number them. When you get fluent at this, like Jillian, you can number them before you circle them, but while you're first seeing them, it's handy to circle them. So we're going to number these, and we could go left to right or right to left. Everybody okay with that? And if I number them in the blue way, 1, 2, 3, so 3, 4, 5, 6, 7, 8, 9, 10. Or the black way going backwards, 1, 2, 3, 4, 5, 6, 7, 8. Everybody see how the blue numbering system is better right now? Because it's lower numbers. Okay, so I'm choosing to number it the blue way, not the black way. So if I had an undo button, I'd click it right now and make all those black things disappear. So I'm only looking at the blue numbering system.
Right, so that's how you choose which numbering systems. The lower number.
The lower numbers. Sometimes you need to add them up because they're pretty close. So you add them up and it'd be the lower total.
Oh, you add the
Yeah, 4 plus, or 3 plus 4 plus 7 versus 7 plus 4 plus 7 plus 8. But it's obvious that that's going to give you a lower total,
Yeah.
the blue line. So, okay, but sometimes it's not so obvious and you might need to add. So I'm ignoring the black. I'm ignoring the black numbering system. If I could rub it out, I really would. Okay. Okay, and then now I need to tell the game which branch is on which number. And I do this alphabetically in terms of the branches. So ethyl gets priority over methyl. Okay, because E comes before M in the alphabet. So where is my ethyl? On carbon 3. So this is going to be 3 ethyl. Where's this methyl? On carbon 4. So this is 4 methyl, and this is of carbon 7. So I'm going to write down 3 dash ethyl, because the ethyl's on carbon 3. Dash 4 comma 7. What do I need to write now? Dimethyl. Can you see that?
Yeah. You can see it.
You can see it? And then ending with decane. And by the way, for those of you that are doing this above and beyond or want to be a bit more pedantic, dimethyldecaine is all one word. There's no space there between the methyl and the dec. Okay, so dimethyldecaine, all one word, all crammed together. If I was typing it, I wouldn't put a space bar. You put a dash between numbers and letters, a comma between two numbers, but I'm not that worried about that right now. Right now, I'm more worried about, can you find your ethyl? Can you find your methyl? Do you know there's two of them? Can you do the numbering system? And can you find the longest chain? And you will see that this booklet, the rest of this booklet is about practicing that. So here I've put, this next section, so naming, this here is all rules of nomenclature, but they're quite like, yeah, long-winded. Here I put them just a little bit in my own words, just a little bit. So, but it's the same thing. It's just a little bit more grassroots. And I've got the branches here: methyl, ethyl, etc. Look what we put with a Cl, chloro, and a Br, bromo. So you're gonna have to look at those. So box the longest chain, circle the branches, name them. Number the chain, left to right or right to left, depending on which set of numbers is lowest. Girls? And here's some examples. So let's try, before the end of class, let's try naming these examples. Then when you come back on Monday, we just practice. And practice and practice. Okay? So let's name these ones together. Or do you do it on your own?
No, let's do the first couple.
First couple together. Okay. So Raj, what's the first thing I do?
Make a chain.
Make a chain. So where can you see your longest chain here? How many carbons?
4.
Jacob?
4.
4. 1, 2, 3, 4. Right there. So put a box around my chain. And then next thing I do is circle the branches. So there's a branch there. So what's that branch called? Methyl. And what's that chain called? Bute. I didn't hear you actually. Butane. And now I do what?
Number them.
Number them. Right to left or right or left to right. 1, 2, 3, 4. Or 1, 2, 3, 4. So which number's lower? 2 or 3, my little grade winners? 2. And so therefore I pick the red numbering system. And so this becomes 2 dash methyl butane. Methyl butane, all one word. Who's there? I don't mean who's there, I'm sorry. I meant who got it? Who's with me? Good. All right. I think the camera's disappeared. Okay, so try the other 3 examples on your own, and then I'll put them on the board in a second.